Step outside on a clear afternoon and look up. One sun, one burning star sitting alone in a vast blue sky, so bright you cannot stare at it directly. You have done this your entire life. Every human who ever lived has done the same. But what if that was wrong? What if the sky above you held not one sun but two? The real answer to that question is far stranger and far more terrifying than you expect. Most stars in the universe do not live alone. That fact alone should stop you cold. When astronomers survey the night sky, they find that somewhere between 50 and 85% of all sun-like stars exist in pairs, binary systems, two stars locked in a gravitational dance around each other. Our own sun is the exception. A single star sitting quietly at the center of its system is, statistically speaking, the odd one out. So the question is not as fantastical as it sounds. The question is, what if Earth had formed the way most planets form, in orbit around two suns instead of one? To understand what that would mean, you first need to understand what a binary star system actually is. Two stars do not simply sit side by side like headlights on a car. They orbit each other. They pull at each other with gravity. And depending on how far apart they are, that gravitational tug changes everything. The shape of their orbits, the radiation they emit, and most critically, whether any planet nearby could survive long enough for life to emerge. Astronomers call the zone where liquid water can exist on a planet's surface the habitable zone. It is also called the Goldilocks zone. Not too hot, not too cold, just right. Around a single star, that zone is a relatively stable band of space. Around two stars, it becomes something far more complicated. Here's where it gets strange. Imagine two versions of a binary system. In the first, the two stars are far apart, so far that a planet like Earth could orbit just one of them, barely noticing the second star as anything more than a very bright point of light in its sky. This is called an S-type orbit. The planet circles one star, while the second star orbits both of them from a great distance. In this scenario, life might be possible. The planet would still have seasons, still have a stable enough climate, though it would have two shadows on certain days and two sunsets under the right conditions. Strange, but survivable. In the second version, the two stars are close together. So close that a planet cannot orbit just one of them. It has to orbit both, sweeping a wide path around the entire pair. This is called a P-type orbit or a circumbinary orbit. You may have seen this depicted in science fiction. The most famous example is the twin sunset on Tatooine in Star Wars. Two suns sinking below a desert horizon. Poetic, beautiful, and as it turns out, not entirely impossible. In 2011, NASA's Kepler space telescope discovered a real planet doing exactly this. It was named Kepler 16b, a planet orbiting two stars simultaneously, situated just outside what scientists calculated to be the binary system's habitable zone. Lawrence Doyle, an astronomer at the SETI Institute and the lead author of the discovery paper, called it the first confirmed circumbinary planet, a world with two suns. It could not support life as we know it, but it existed. The universe had already done the experiment. So what if Earth were Kepler 16b except moved slightly inward, just close enough to both suns to sit inside that habitable zone? What would your life actually look like? Start with light. On a binary Earth, the concept of a single sunrise becomes almost meaningless. The two stars would rise and set at different times, depending on where they were in their mutual orbit. Some mornings you might wake to both suns already above the horizon, a blazing, doubled light, no true shadows, everything washed in a flat, directionless brightness. Other mornings, one sun would rise first, casting long shadows toward the east, and then an hour or two later, a second, slightly smaller or cooler sun would lift above the horizon from a different angle. Your shadow would split. You would cast two shadows simultaneously, pointing in slightly different directions. Every object on Earth would do the same. Night, if it came at all, would be shorter, much shorter. In some configurations of a binary system, the two stars would take turns keeping the sky lit. True darkness, the kind your ancestors evolved inside, the kind that allowed them to see the Milky Way overhead and navigate by stars, might become rare or seasonal or in extreme cases almost non-existent. Think about what that would do to life. Every organism on Earth evolved with a circadian rhythm, an internal clock tuned to the 24-hour cycle of light and dark. Remove the dark or make it unpredictable, and that clock breaks. Sleep patterns shatter. Hormones misfire. The biological machinery that evolution spent hundreds of millions of years building for a single sun world would have to be rebuilt from scratch for two. But light is only the beginning of what changes. Heat becomes wildly unstable. In a binary system, the two stars are not static. They are orbiting each other. That means the total amount of radiation hitting your planet's surface changes over time. Sometimes both suns are on the same side of the sky, their heat combining, and your planet warms. Sometimes they are on opposite sides and the heating is more balanced. Seasons on a binary Earth would not be driven just by axial tilt the way they are on our planet. They would be driven by the ever-shifting geometry of two moving heat sources. Some years might be dramatically hotter, others cooler. The climate, instead of cycling in a predictable annual pattern, would pulse in complex rhythms, rhythms that might take decades or even centuries to complete one full cycle. Konstantin Batygin, a planetary scientist at Caltech, has studied the orbital dynamics of planets in binary systems extensively. His models suggest that the gravitational interplay between two stars creates what he calls orbital chaos, periods of relative stability interrupted by sudden dramatic shifts in a planet's path. A planet can be nudged, pulled slightly closer to one star during certain orbital alignments, pushed slightly outward during others. Over millions of years, this produces a climate record unlike anything in Earth's history. Not the slow, grinding ice ages your planet has experienced, but sudden swings, sharp lurches from warm to cold and back again, potentially happening faster than life can adapt. And that raises the deepest question of all. Could life even start? The origin of life on Earth required something remarkable: stability. Billions of years of relatively consistent conditions. Liquid oceans staying liquid. A magnetic field holding. An atmosphere staying thick enough to protect the chemistry below from lethal radiation. Astrobiologist Sarah Seeger at MIT has argued that this long-term stability is one of the most underappreciated requirements for life to emerge. You need not just the right chemistry, you need the right chemistry to persist undisturbed for an almost incomprehensible length of time. In a binary system, that stability is harder to guarantee. The gravitational tugs, the shifting seasons, the erratic climate, all of it creates more opportunities for catastrophe. One bad orbital shift and your liquid ocean freezes. One close approach between the two stars and your atmosphere begins to erode faster than it can regenerate. This does not mean life is impossible around binary stars. It means life, if it exists there, would be shaped by an entirely different set of pressures. It would be life that evolved for chaos. Life that thrives in unpredictability. Life that perhaps developed entirely different biological strategies, more adaptable metabolisms, faster reproduction cycles, organisms that can survive in a wider range of temperatures because their sun has never been fully reliable. Now mirror this back onto you. You live under one sun, one reliable burning star that has been doing the same thing for 4.6 billion years. It rises, it sets, it keeps your planet warm without cooking it. It has given life on Earth the one thing life needs most, not just energy, but the gift of predictability. Your body knows the rhythm of this sun. Your brain expects it. Your sleep, your hunger, your mood, your hormones, all of it is synchronized to a single star's single daily cycle. When that cycle is disrupted even slightly, shift work, jet lag, seasons with extreme day length, your body protests, your health declines, your cognition suffers. Researchers at Harvard Medical School have linked disrupted circadian rhythms to everything from metabolic disease to increased cancer risk. You were built for one sun. And one sun, it turns out, is extraordinarily rare in a universe full of pairs. So the next time you step outside on a clear afternoon and look up, remember what you are actually seeing, not just a star, a singularity, a lonely, stable, perfectly calibrated source of warmth in a universe where two-star systems are the default. The sky above you is not normal by cosmic standards. It is a gift, a fluke, a once-in-a-galaxy arrangement that made the entire story of life on this planet possible. There is only one sun above you right now. And it turns out, that is the most extraordinary thing about the world you live in.